You're very impressive, son. Okay, let us get started. All right, we are so close to the end, guys. It's making me happy. Not because I dislike being around you guys, but I hate this system of trying to teach online, so I will be happy. And I hope post-secondary is open, even though they say they're not going to. We will see. I hope they're just planning for the worst. All right, so today we are going to talk about female reproductive system. And then tomorrow we're going to finish it off. So we might end a little bit early tomorrow, but I'm going to review some of the stuff that we do today tomorrow, because some of the stuff that's involved, the steps involved in the menstruation or menstrual cycle are a little bit difficult to get our heads around. So we're going to do that twice. Okay, so we'll do a bit of it today, and then we're going to do it again tomorrow, and hopefully it'll all stick. Also, don't forget the male reproduction quiz open today at noon. It closes Friday at noon. So I don't have a worksheet for you today. I might make one up and post it, but your worksheet won't be due until Sunday night, because we have 2 classes of female reproduction today and tomorrow. And then Tuesday through Thursday, I'll open up a female reproduction quiz. And then the next week, that's when we'll have our final test for reproduction. So our last section after female reproduction is fetal development. And then when we're done that, we're done. So we are almost there. So just push, push, push for another 2 weeks. That's it. And we're there. Just a reminder to you guys, remember there is no class on Friday. We have class tomorrow instead. Okay, so our class will be tomorrow instead of Friday. So just remind yourself of that. I did put it in my class notes after last lecture, and I'll do that again today. Okay, without further ado, let us get started here. So I will share my screen. And we'll get going. Okay, we're just gonna go back a little bit. Just trying to go to talk about follicles a little bit. Oh goodness, this is deciding it wants to fall asleep on me here. Did all this. We talked about anatomy. We talked about function. And okay, this is about where I wanted to start. I know we did this part already, but we're just going to review a little bit. Okay. So we're just going to be a little bit of the cross-section ovary. I went into this system a little bit. Remember that we have an oocyte developed in this sac. So we have this big sac of cells, a whole lot of sacs actually, a whole lot of sacs. They're called follicles. So the ovaries have a whole lot of follicles. So if we look, just get my spotlight here. If we look here, right, what we're seeing are these little teeny tiny follicles. They have almost no granulosa cells. So the outside would just have this little flat layer of granulosa cells, and this is an oocyte, and this is an oocyte, and this is an oocyte. And here we see this is one great big large follicle. This is an oocyte. I can see the nucleus of the oocyte, so it's a very large cell. And then all these little purpley things, those are teeny tiny little granulosa cells that are helping to provide nutrients to that developing oocyte. So we'll just look at this. So our follicles, so those are all examples of follicles, right? There's the oocyte, and I could have colored these in purple as well because they're oocytes, or sorry, blue, they're oocytes, okay? And if I look at this image, so I've circled follicles, I could have circled this down here as well. And then when we look at the follicles, inside the follicles we have oocytes, right? And this here would be an oocyte as well, but there's really not much for granulosa cells. So those are oocytes. And here we have the granulosa cells that are surrounding the oocyte. So this is just a whole lot of granulosa cells. Here we see granulosa cells, they're surrounding the oocyte, and then here we have this little layer of liquid. It's called the antrum. We don't need to know that, but it's all liquid. And it looks a little bit purpley here. That's just because some of the crystals in the liquid take on the dye. Okay. Another one here, we're looking at follicle. This is a great big giant follicle. These are little follicles. And then when I look at this, there's the oocyte. These would also be oocytes. And then all of these cells we see here, all these little pink dots, those are all granulosa cells. And then this is a whole lot of liquid that's in there. So this is pretty mature as far as a follicle goes, because the amount of liquid and the size really determine if that's going to be the oocyte that gets ovulated. Okay. All right. So then we took a look at this. So we were looking at this whole process of oogenesis, right? So if we just take a look at the top here, we have our primary oocyte. And I just wanted to, again, highlight the idea that we're looking at follicles here, right? So follicles are the sac that have the granulosa cells and the oocyte. So this would be a little follicle as well. And then in green, I've colored the oocytes. And then in red, I've colored the polar bodies. So we want to remember, and what I like about this image is it really shows us what's happening, because often we look at this image as being, when the oocyte divides, we have this big side and then we have this little side, but really they're jam-packed together inside that follicle, right? So we can see the secondary oocyte at the first polar body, and then that secondary oocyte is ovulated, and then if fertilization happens, then that second polar body will form. Okay. All right. So the primary oocyte undergoes meiosis 1. So most of the cytoplasm and nutrients go to one pole when that divides. So we get a secondary oocyte. So I put the ploidy here. So the primary oocyte is 2N. That means a mom and dad copy of every chromosome. That separates, right? So metaphase 1 occurs. They line up, the mom and dad copies of the chromosomes, and then anaphase 1 happens, and then those separate to opposite poles, right? So the resulting cells are a secondary oocyte and a polar body. They both have only a mom or a dad copy of each type of chromosome now, okay? The polar body will die because there's not enough nutrients to sustain it. The secondary oocyte is ovulated. It goes into the fallopian tube. So remember, it's ovulated, captured by the fimbria of the fallopian tube. If fertilized, then the secondary oocyte will undergo meiosis 2. Okay, so meiosis 2 would happen in the fallopian tube. Meiosis 1 occurs in the ovary. So most, again, this is an asymmetrical cytokinesis. Most of the cytoplasm goes to one side, tiny bit of cytoplasm goes to the other side. So we get this mature ovum and a polar body. So this ovum goes from N to 2N very quickly because fertilization has occurred. Okay. All right. This is just an interesting graph to kind of look at. Just going to get down just a little bit. How many oocytes we have in our ovaries, right? So this is the number of oocytes that we have. So we're thinking about primary oocytes, the ones that are going to kick off meiosis. And this is the age of the individual. So here's when the girl is being born. 2 months, right? So this is at about 7 months after conception. So 2 months before you were born is when you had the most primary oocytes. Weird thought to think of. So this little unborn girl has about 7 million primary oocytes in her little ovaries. Then she's born. Then finally we hit puberty. At puberty, we have about 400,000 primary oocytes. Okay. So at puberty, the ovary has about 400,000. That number varies depending on the resource that you look at. And then what happens? So if we look here, right? Remember meiosis, right? So we go through meiosis, prophase 1, metaphase 1, anaphase 1. Well, what happens is all of those primary oocytes before we're born, they all start going through meiosis and then they stop. It's like someone pushed this great big giant pause button and they all sort of stop. Over time, a lot of them have died. So we're at 400,000. Then when the girl hits puberty, it's like this big pause button comes up, and about 1,000 of those primary oocytes start to develop. But the thing is, most of them will die off when they're just the teeny tiny, very little granulosa cells. Eventually we get to one single really large follicle where that secondary oocyte is ovulated. Okay, so out of the 1,000 where that pause button lifts, only about one ends up being ovulated, sometimes two, which can lead to fraternal twins. Okay, so only one ovum eventually reaches maturity. So even though this says 400,000, really we only are going to ovulate about 400 to 500 times in our lifetime. That averages to about 35 years. So our time of being reproductive is about 35 years. Okay, different from a guy. When they hit puberty, they become these sperm-making factories. They can actually still have children up until their 80s, as long as they're producing sperm, which they can be. Okay, women, we have that window. Okay, all right. So let's take a look here. So again, I've just shown a little bit about oogenesis. So we have our ovarian cell, and it's kind of like the spermatogonium, right? So this is an oogonium. It undergoes mitosis to produce a primary oocyte. But this has all happened before we were born, okay? The primary oocyte undergoes meiosis 1. So remind me in the chat, where in the body does meiosis 1 occur? Where in the body does meiosis 1 occur, the female body? Okay, I've got 10 of you out there, guys. Where in the body? Sort of sucks when you don't have your slides in front of you so you can go back and look at it, I know. Where in the body does that first meiotic division happen? No risk takers today. Okay, remember that first meiotic division occurs in the ovaries. Yes, thank you, Larkin, the ovaries. Okay. All right, so we have the first meiotic division. So with that division, we have that secondary oocyte, lots and lots of cytoplasm, and then this teeny tiny little polar body, very little cytoplasm. So even though it has, you know, haploid number of chromosomes, it dies. Okay. All right. That secondary oocyte is ovulated. Okay. Fertilization, if it happens, then we undergo meiosis 2, and meiosis 2 occurs in the fallopian tube. Okay, and we're talking typical, right? We talked about ectopic pregnancies where fertilization can happen in different spots. We always want to assume that it's typical unless you're told differently, okay? So typically fertilization happens in the fallopian tube, and then that fertilized egg will move down the fallopian tube, being moved by the cilia. Okay. All right, now the other structure we have to talk about is something called the corpus luteum. Okay, so we have all these weird sort of sounding words that we have to learn. So the corpus luteum. So what happens with the corpus luteum, or what is it? When ovulation happens, right, that secondary oocyte is leaving the ovary and it's going to be captured by the fimbria, going to go into the fallopian tube. Okay, so that's what we see happening here. Ovulation has occurred, that secondary oocyte goes to the fallopian tube. But these remaining follicular cells, through some hormonal stimulation we'll talk about a little later, these remaining follicular cells transform into this structure that is called the corpus luteum. Okay, so corpus luteum is formed by the follicle cells that remain after ovulation. So why do we care about this structure? We care about it because this structure produces a couple of hormones called estrogen and progesterone. So those are the female sex hormones, and they're produced by our ovaries, right? So specifically in our ovaries, they're produced by the corpus luteum. Okay, what happens to the corpus luteum is there's a negative feedback mechanism that occurs, and that corpus luteum can be turned into scar tissue. And that's a negative feedback. We'll talk about the negative feedback that causes that to happen. And this little piece of scar tissue is a structure called the corpus albicans. So if we ovulate 400 to 500 times, that means that we'll have 400 to 500 little corpus albicans, these little scar tissues on our ovaries. Okay. All right, so I have a little video that we're going to watch. There's some words in the video that I haven't mentioned at all. Don't worry about those words. Worry about the stuff that I have talked about. Okay, so we'll just open this up. I'll share that with you.
And a well-developed capsule, or theca, becomes apparent around the granule.
Let's just make this do what I want it to do here.
And a primordial follicle consists of an oocyte surrounded by a single layer of squamous granulosa cells.
Okay, so primordial follicle, and we don't have to know the names of all these different follicles, but basically what this means is it's hasn't really developed. So that's like the little ones that we were looking at in those images. So they have this oocyte with just a thin layer of granulosa cells over them. So they are still a sac, but there's really not much in there other than the oocyte. Okay, so these are the really primitive form.
A primordial follicle becomes a primary follicle as the granulosa cells become enlarged and cuboidal. The primary follicle enlarges and the granulosa cells form more than one layer. The zona pellucida forms around the oocyte.
Okay, so zona pellucida, we don't need to know the name of that. Really what we're just looking at is these images. So we see that as the follicle matures, we get more and more granulosa cells in it, which means we're getting closer to the point of ovulation.
The structure is called a secondary follicle when fluid-filled vesicles develop among the granulosa cells and a well-developed capsule, or theca, becomes apparent around the granulosa cells.
Okay, so we know it's getting more mature when we see we've got these, let me just look at my spotlight here. We see granulosa cells around the oocyte, and then we see they're all in the inner layer here, and then liquid. So it's starting to become a more mature follicle.
The theca possesses internal and external layers.
We don't need to know about that.
The structure is called a mature follicle when the fluid-filled vesicles form a single antrum. At full maturity,
sorry about that. Let me try this again. I didn't realize I wasn't sharing with you. Okay, so let's go here. Let's try that again. Okay, can you guys see this? Just give me a quick yes or no on the chat. Okay, all right, so we're good now. Sorry about that. Okay, let's try that again.
a primordial follicle consists of an oocyte surrounded by a single layer of squamous granulosa cells. A primordial follicle becomes a primary follicle as the granulosa cells become enlarged and cuboidal. The primary follicle enlarges and the granulosa cells form more than one layer. The zona pellucida forms around the oocyte. The structure is called a secondary follicle when fluid-filled vesicles develop among the granulosa cells and a well-developed capsule, or theca, becomes apparent around the granulosa cells. The theca possesses internal and external layers. The structure is called a mature follicle when the fluid-filled vesicles form a single antrum. At full maturity,
okay, so what they're looking at here with this one is when we start seeing that this fluid-filled space is now one great big space. So if we look at the size of this follicle compared to that primordial follicle we started with, we know that it's getting close to ovulation. So this is the one that's probably going to ovulate, where a lot of them are going to stay that small size out of that 1,000 where that pause button lifts up. Okay, so
oocyte is located in the cumulus mass. During ovulation, the oocyte is released from the follicle, along with some surrounding granulosa cells of the cumulus mass, called the corona radiata.
Okay, again, we don't need to know that word, but what we can see is the secondary oocyte is surrounded by a bunch of follicular cells. That whole structure of those follicular cells and the secondary oocyte, that's what's being captured by the fimbria and is going to go into the fallopian tube.
Following ovulation, the granulosa cells divide rapidly and enlarge to form the yellow corpus luteum. When the corpus luteum degenerates,
okay, so remember the corpus luteum is in the ovary, okay, because the corpus luteum is what's remaining, those cells that are left behind after ovulation, they, through some hormonal action we'll talk about, get converted into this corpus luteum.
it forms the white corpus albicans.
That's scar tissue, and that'll happen through a negative feedback mechanism. Okay. All right. So that's just a little bit looking at the, starting with a really primitive egg cell, oocyte, and then going to more mature, and then what happens to those cells. So I quite like this video for that. Okay. So now let's go back and see if we can properly share the notes with you here. There. All right, so these images, and you see these images a lot when you look up ovary, so any kind of illustration of an ovary, you're gonna see something like this, right? Where we start with those really immature follicles, starts to grow a little bit more, but we can see the oocyte here, right? So the oocyte is this little yellow spot, so that's what we're seeing here. There's an oocyte, that's that little, and we can see the nucleus in it, right? And we can see how the follicles are getting bigger and bigger, and we see that there's more granulosa cells, right? So all of this pink here that's surrounding, those are all granulosa cells. And then that whole entire structure, right? This structure here and this structure here, those are all follicles, okay? Now this is an empty follicle, right? It doesn't have the egg in it. So these remaining follicular cells get converted into the corpus luteum through some hormonal action. Okay, let's go back into that. All right. So again, we can see this just from a different point of view because these images are the ones that you're going to see the most, right? We're starting with these really immature follicles, more mature. So we have more granulosa cells with some liquid, a whole lot of liquid, right? This whole entire structure is a follicle. So we see how it's starting to press against the side of the ovary distends, and we have this release of the secondary oocyte along with granulosa cells. These remaining cells become the corpus luteum, which is a little hormone factory. Okay. All right, so this just goes through a little bit differently way to look at it. So let's just start at the top of this diagram. What I like about this is it talks about what's happening before we're born. So we see in this big square here, this is what's going on before we're born, is the oogonium gets converted or reproduces through mitosis to make primary oocytes. All of those primary oocytes, all 7 million of them, start meiosis 1, but they stop kind of partway through prophase 1. And then when we hit puberty, big pause button lifts up. So what we're seeing here, this is still what's going on. So this has an outline here of a little square as well. This is still what's going on while we're still in utero. So we're not even born yet, okay? Then meiosis 1 finishes off. We get the secondary oocyte and the first polar body, okay? Secondary oocyte doesn't complete meiosis 2. It kind of starts meiosis 2, but it doesn't complete it, and it won't complete it unless fertilization occurs. Okay. All right. Now we get to talk about the menstrual cycle. So we have to know how all the hormones and everything fit together to create the menstrual cycle. Okay. So the menstrual cycle, we often, when we menstruate, when we start menstruating for the month, we call it that we're having our period. But when we think about what a period means, A period is really a cycle of events that recurs each time, right? So when you think about a period for a wave, right? Up and down and back to where we started with is a period. So we're looking at that series of events that's happening, and then it starts again and starts again. So we need to understand that cycle or series of events, all the hormones that are responsible for each one of those stages of events, okay? So menstrual cycle, a monthly cycle of events involving the ovaries and the uterus. So often that gets broken down into the ovarian cycle and then the uterine cycle, okay? But all of these are dependent on the different hormone amounts in the body, okay? The typical cycle is 28 days, okay? So whenever we talk numbers, we're gonna be referring always to a typical 28-day cycle. Now, you guys may not know this, but girls, you will. Not a lot of women have a typical 28-day cycle unless they're on birth control. If they're on birth control, then that keeps us up to those dates because it manipulates those hormones through synthetic hormones. But women who aren't on birth control could have a 29-day cycle or a 32-day cycle or a 24-day cycle, right? Or they could have a 24-day cycle, then a 32-day cycle, and then a 17-day cycle. That suck for them, but yeah, okay? So they can be all over the map. The hormones that control our cycling are GnRH, LH, FSH, so gonadotropin releasing hormone, luteinizing hormone, follicle stimulating hormone. These ones here we recognize because we've seen them with the male reproductive system. And then the ovarian hormones, estrogen and progesterone, okay? So the ones produced by the pituitary gland are LH and FSH. The ones produced by the ovary are estrogen and progesterone. And of course, GnRH is produced by the hypothalamus. All right, so let's just take a look at this graph, right? So we see what's going on with the follicles, right? So primordial, we see the follicle is developing until ovulation happens, and then the remaining cells become the corpus luteum. Here we see the fluctuation in hormones, and we're going to talk a little bit about what those fluctuations mean and how to recognize different hormones. Here's a days of the cycle. So we can see that flow phase has occurred here. So I marked that up at the top there. So we have flow phase. Flow phase is the shedding of the endometrial lining. The building of the endometrium happens through our cycle, and then it sheds again, okay? All right, so we're going to talk about those and all the hormonal processes involved in that. So let's move on. Okay, so hormones. So the production of ova, so remember ova is the plural for ovum. So the production of ovum is egg. Production of ova, progesterone and estrogen is all controlled by the hypothalamus and the pituitary, okay? So this is like our male reproductive system. So we hit puberty, hypothalamus releases the gonadotropin releasing hormone. So remember that hormone comes from the hypothalamus, it targets the anterior pituitary, tells the anterior pituitary to release FSH, follicle stimulating hormone. Okay. So the first phase we're going to talk about with the menstrual cycle is called the follicular phase. Follicular phase, again, we're talking about a typical 28-day cycle, occurs about day 6 to day 13 of the menstrual cycle, okay? It begins with the release of the follicular or follicle stimulating hormone. Well, a follicle stimulating hormone is going to stimulate follicles. We now know a follicle is that sac that has the oocyte and a whole lot of granulosa cells, right? So follicle stimulating hormone will stimulate that sac, begins with the release of FSH. Okay, so what does FSH do? FSH is causing those follicles to develop. So what does that mean? The follicles are getting bigger. There's more granulosa cells in the follicle, and eventually we're going to have that fluid level in the follicle, and meiosis is kicking off, right? So when we talk about the follicle developing, more granulosa cells and the continuation of the phases of meiosis. Remember, pause button was pushed. We're lifting the pause button and continuing on with meiosis. The other thing that FSH does is it tells those follicles, particularly the granulosa cells or the follicular cells, to secrete estrogen. Okay, so now the estrogen level starts to go up. Okay, All right, so we're just going to take a little pause and talk about estrogen. So while testosterone for the men is responsible for the secondary sex characteristics of the men, estrogen is responsible for the secondary female sex characteristics. So one of the major ones here is the thickening of the endometrium, or one of the main responsibilities of estrogen is the thickening of the endometrium. Okay. Other things, breast development. So the rest of them you've all heard about in your sex ed classes. Breast development, body hair, right? So pubic hair and underarm hair start. Hips widen, the body becomes more rounded, right? Eventually we have to push a baby through those hips. So the hips get rounded with breast development. So we talked about a guy, we talked about having more of this sort of upside down pyramid shape, broad shoulders, narrow hips. With a girl, we have that hourglass shape, right? Breasts and hips. The uterus and vagina mature and increase in size, okay? Now, estrogen also increases the amount of body oils that we have. So again, girls also have to take showers on a more regular basis than they did before they hit puberty, okay? All right, back to the hormone stuff. Follicular phase. All right, so there's two feedback systems at the end of the follicular phase. There's a negative feedback system and a positive feedback system, okay? So when we talk about the hormonal control in the female system, it's quite a bit more complicated than the male system, okay? So negative feedback, high levels of estrogen. So remember, these follicles, they're secreting estrogen right now, okay? So here's our follicles. We've got all these little granulosa cells. They're releasing estrogen. So the level of estrogen is getting higher and higher in the blood, okay? Once it gets to be too high, it sends a message back to the pituitary gland, and it tells the pituitary gland, okay, we're good, shut off FSH production. We don't need any more, okay? So it shuts off FSH. Let's just clear this here. So secretion of FSH is inhibited. So what we're going to notice is a little dip in the FSH. Now, if FSH is dipping, because remember, what we have here is we've got our follicle. So here's our follicle, right? FSH is stimulating the follicle to secrete estrogen. But if high levels of estrogen go back to the pituitary, because remember the pituitary is releasing FSH, and they tell the pituitary to stop releasing FSH, right? So stop this, then we don't have FSH, which means the follicles aren't stimulated, which means our estrogen levels go down, right? So FSH stimulates the follicles to secrete estrogen. Estrogen levels get to be too high, sends a message to the pituitary saying, shut off FSH production. That goes down, follicles aren't stimulated anymore, so estrogen level goes down. So we'll actually see peak in estrogen and then a dip, okay? All right. So without stimulation of the follicles, estrogen levels drop. All right, so that's our negative feedback. However, we have a positive feedback. That high level of estrogen, and only at the end of follicular phase, that high level of estrogen sends a message back. So if we look at it, so we've got to remember what's going on here. So here's our follicle, right? And we know here we've got FSH stimulating the follicle, follicle secreting estrogen, right? Estrogen goes back to the pituitary. But what it does is it says, hey, pituitary, release LH. So then, let's make a screen. The pituitary releases this hormone called LH, luteinizing hormone. Okay, so high levels of estrogen at mid-cycle tell the pituitary to stop releasing FSH, but they tell the pituitary to release this hormone, LH. Okay. All right. say a little tiny bit more complicated. Who said girls were more complicated than guys, hey? All right, so we'll just clear my drawings here. And that. Okay, so stimulates the release of LH. Now, so what we have is we have this big surge of LH. That LH targets that last remaining developing follicle, that really mature one, and causes ovulation to happen. So high levels of LH stimulate ovulation. Okay, so now we have the ovulatory phase. A lot of resources don't refer to it as a phase because it really isn't. It's more an event, right? But we'll call it that. So day 14 of the menstrual cycle is when we ovulate. Okay. If you have a cycle that's different than a 28-day cycle, right? If you're not on birth control, if you're on birth control, then you're probably not ovulating. But usually it's 2 weeks before you have your period. So if you have a 34-day cycle, let's say, then on day 20 is when you ovulated. So it's usually about 2 weeks before, okay? But we're always talking about typical, so 14-day. High levels of LH cause ovulation to occur. If a couple is trying to get pregnant, they can actually purchase an LH kit. So she can check, because if we have high LH in our blood, then we're going to be having high LH in our urine. So you can pee on a stick and it can indicate where your levels are and if you're ovulating. Because then if you have intercourse within 24 hours of that, there's an increased likelihood of getting pregnant. Conversely, you never want to use this as a form of birth control. It's a terrible form of birth control because you never know for sure exactly when you ovulate. Too many things can affect when you ovulate. Okay. All right. So far so good. So we've started with follicular phase. Ovulation has now happened because of high levels of LH. Okay, so now we're into luteal phase. So this is the last half of the menstrual cycle. Okay, so the luteal phase, so about day 15 to day 28 of the menstrual cycle. So remember, we have high LH. So high LH, first of all, it caused that secondary oocyte to be released, so it caused ovulation to happen. But it does a couple other things, okay? What it does is it transforms those remaining follicular cells that remain after ovulation into the corpus luteum. Oh, sorry, what just happened here? Let's go back to this. Did I push something that I wasn't supposed to push? Okay. Let's just go to this. Why is that? Why have I lost my PowerPoint? I don't know. Hold on a second. Okay, I don't want that. Let's just share that. Okay. There we go. I don't know what happened there. Okay. So luteal phase. So the couple of things that happen here, so I'm going to go back to my draw. Transform the follicular cells that remain. So remember those remaining follicular cells that are in the ovary after ovulation, they get converted into the corpus luteum. That happens because of LH, okay? And then what LH does is it maintains the corpus luteum, so it keeps that structure going. So if we don't have LH, that corpus luteum is not being maintained, okay? All right. Remember, the corpus luteum produces hormones, estrogen and progesterone. Now, we're going to take a little interlude again just to talk about progesterone. So progesterone is another ovarian hormone. It's produced by the ovaries. The corpus luteum is in the ovaries. Progesterone is responsible for increasing the vascularization of the endometrium. That's a big mouthful. Vascular, that's blood vessels. So vascularization, we have more blood vessels, right? So the endometrium is going to allow for estrogen allows for the endometrium to start to thicken The progesterone is really what's getting it ready for that impending embryo, right? So more blood vessels, more nutrients to be provided. It works to prevent uterine contractions. So if our level of progesterone is high, then the woman's not going to go through uterine contractions, right? Which is good because we don't want to have contractions until the pregnancy is over. Prevents further ovulation. So there's negative feedback mechanisms that keep us from ovulating when progesterone levels are high. Okay. All right. So let's finish off luteal phase. So luteal phase, high levels of estrogen after ovulation and progesterone inhibit the pituitary release of FSH and LH. Okay, so when estrogen level and progesterone levels are high, so remember they're being produced by the corpus luteum, so these levels are high, they send a message back to the pituitary saying, shut off FSH and LH. Okay, now let's think about this. What's LH doing for us right now? Does it have a job? Does anyone remember the job LH is doing for us right now? Okay, so LH is maintaining the corpus luteum. So we have these high levels of estrogen and progesterone. They're sending this message to shut off LH production. Well, what's that going to do to our corpus luteum? The corpus luteum isn't maintained anymore, so it disintegrates. Well, the corpus luteum was producing hormones. It was producing estrogen and progesterone. So if we don't have the corpus luteum being maintained and it deteriorates, then estrogen and progesterone aren't being released. So if they're not being released, then there's no more maintenance of the endometrium, right? So the blood vessels start to constrict, they pull away, and the endometrial lining is shed. Okay, and that's when we menstruate or have our period, right? That's usually what those terms that we use. Okay. All right. So without a functioning corpus luteum, estrogen and progesterone are no longer released. So that gets us into flow phase. Now, flow phase, day 1 to 5 of the menstrual cycle. Okay. Now, the reason why I started with follicular phase is when a girl first starts to go through puberty, she doesn't start with flow phase. She starts with follicular phase. Flow phase is designated day 1 because that's the one we know, right? Because when we hit flow phase, it's like, yippee, okay? We don't know when we start follicular phase. We don't know when we ovulate. We don't know when we start luteal phase, but we do know when we start flow phase. So when you go for an x-ray, for example, or certain blood tests, they'll say, when was the first day of your last menstrual period, right? That's the one we know. That's day 1. So that's when our endometrial layer is shed, okay? All right, so I have a question for you. So I just need a yes or a no here. Can a girl who has not had her period yet, but who has sex, okay, she hasn't had her period, but she's having sex. Don't think about that too hard because 12-year-olds having sex is icky. But we're talking about biology. Can she get pregnant? So I just want you to enter a yes or a no. What do you think? Okay, a girl who hasn't menstruated, can she get pregnant? Okay, I got 10 of you that can take a risk. I'm not marking this. Come on, take a risk. Can she get pregnant? Yes or no? Okay, hasn't had her period yet. Can she get pregnant? Okay. I'm seeing a whole lot of no's. She can. If she hasn't had her period yet, she can still get pregnant. Okay, let me show you. So I'm just going to go backwards in my slides here. Okay, and we'll talk about this little girl. Follicular phase, right? She hasn't had her period yet, right? She hasn't menstruated because her endometrial lining hasn't thickened enough for her to menstruate. But FSH is being released. Causes the follicular cells to secrete estrogen. Estrogen is causing the thickening of the endometrium. It's starting to thicken, okay? And then LH happens. LH is released because of that high level of estrogen at mid-cycle. LH causes ovulation. Now notice, she can ovulate before she menstruates. Because after ovulation, we get to luteal phase, right? Where the corpus luteum secreting estrogen and progesterone, and now we have more vascularization, right? Preparing for that impending embryo. So she could get pregnant because she's ovulated. The progesterone is going to prepare that endometrial lining for that impending embryo, and if she does get pregnant, she just won't menstruate until 9 months later. Oh, a little bit after those 9 months. Okay, does that reasoning make sense? Okay, so again, you'd have to be incredibly unlucky, and we don't want to talk about really little kids having sex, but thinking of the biology of it, it is possible. Okay, all right, so we're going to end there. So what I'm going to do is we're going to review. So what I would like you guys to do tonight, because you've finished the male reproductive system worksheet, make sure you get the quiz done. Just review these phases, because what we're going to do tomorrow is we're going to start the class by working backwards through the phases. What causes what to happen? So I really want you to think about, because I want you all to participate in this, I want you to think about what stimulates each step. So you're going to have to review your notes and kind of think about it. Maybe even go through your textbook a little bit. I'll suggest some readings for you to help you with that. Okay, so finish the male reproduction and then kind of just review your notes with that. Don't forget, class is tomorrow. It is not on Friday, okay? So we will have a class tomorrow and we'll finish off the female reproductive system tomorrow. So it looks kind of windy and a little gray out there, but if you have some time to get out there and get some vitamin D, it's probably good for you. And that's it for today, unless you have some questions for me.